Hello students, good morning. Myself Dheeraj Rana, your teacher and motivator. So I think you are preparing for your final exams of March 2022 very dedicatedly and sincerely. So students, today I have taken a 10th class topic and even it is must for SSC and banking exams as per general knowledge or general studies concepts are involved and that of this topic. And our topic today is carbon and its compounds. So let us start with our topic. So students, now first we try to know about the versatile nature and the abundance of the carbon. You know, carbon is such an element which is found even in everything and everywhere. You see that it is an element which is having atomic number 6. It is one of the elements of the periodic P block element, P block of the periodic table. So it is found everywhere in every component almost, and in the universe, in the sun, planets, atmosphere of the earth, everywhere it is found. Now if we look at our surroundings, we find its availability everywhere. See, in the foods you see carbon is found in starch like sugars also, glucose, fructose, mannose, everything is made up of carbon. Then fats, vitamins and proteins. Now if we look at the fuels like wood, coal and petrol, etc., everywhere carbon is their component. In household item like paper, soap, cosmetics, oils, so carbon is there. And in the textile sector, if we go, then we see cotton, wool, silk, linen, rayon, nylon, everything. Their constituent is carbon. If we talk about the drugs like penicillin, quinine, aspirin, etc., a lot of drugs are there. So carbon is the component. Then poisons like opium and strychnine drugs. So there is also carbon, one of the component. In perfumes like vanillin and camphor, carbon is there. So in explosives, TNT hai, trinitrotoluene, dynamite hai, or nitroglycerin hai, everywhere there is carbon in it, their composition. So dyes you see indigo, Congo red, malachite green. There is also carbon as their constituent. In war gases like chloropicrine and mustard gas, carbon is one of the constituent. So you see students, carbon is found everywhere, from simple compound to complex compounds, from our body to the universe, whatever you take as an example, you find carbon there. So this is the richness of this element. Okay, so now we study about this carbon and the compounds formed by carbon. So students, now see, carbon is having atomic number 6. So it is like this: 1, it is its nucleus, first shell and second shell is there. So 1, 2, 3, 4 electrons are here, and 1, 2 electrons are there. Carbon is having atomic number 6. So in the K shell there will be 2 electrons, in the L shell there will be 4 electrons. And if we talk in terms of SPD configuration, then it will be 1s2 and it will be 2s2, 2p2. So there are 4 electrons in its valence shell. So if 4 electrons are there, they are responsible for bond formation with other atoms to form the compounds which are made up of carbon as one of the constituents. So ये है कार्बन की बेसिक जो एक एटम की कंडीशंस है. And you see, we have many types of isotopes of carbon like carbon 12, carbon 13, carbon 14. Okay, and in this also carbon 14 is scientifically very important. Okay, for what? For carbon dating purpose, to know the age of all the old materials. So this was about the carbon. Now students, we try to understand what is its tetravalency and what it does with that. So you see carbon is here, carbon is tetravalency, means its valence shell of carbon has 4 electrons. और वो कौन कौन से हैं? They are 2s2 and 2p2, means they are of L shell. So students, now nature of carbon is that first condition is every element tries to attain a stable configuration, you can say, or noble gas configuration. So means it tries to complete its, attain its, you can say like that, attain its nearest noble gas configuration. Now, in case of carbon, you see there are 4 valence electrons, and 4 valence electrons. Now you see, if carbon loses them, then it forms carbon cation, C positive, to attain helium, because helium has atomic number 2, helium, noble gas configuration. And if carbon gains 4 electrons, to attain 4 electrons, then it becomes carbon anion to become neon, that is having atomic number 10. तो कार्बन में अगर 6 में 4 आप ऐड कर दीजिए, then it will be equal to neon configuration. But you see, this bonding is always coordinated by, assisted by, directed by, instructed by what? Energy considerations. So these two things are energetically not possible for carbon. So carbon, when it forms associative compounds, forms bonds with other elements, it never loses or gains the electrons. Then what happens? What it does? Then we have a term which we are going to discuss now is covalency of carbon. covalency of carbon means how carbon forms bonds. First thing is carbon forms bond in the carbon forms bonds with other atoms. It may be of carbon or it may be other atoms by what? So students, by sharing of electrons. Sharing of electrons means both the atoms share their electrons, both the atoms share their electrons. Sharing of electrons takes place. So such type of bond here is called as, such type of bond is called covalent bond. Because I have already told you that ionic bond carbon नहीं बनाएगा. It will not gain, it will not lose. और जो gaining और lose करने से bond बनता है, that is ionic bond. But in case of carbon, that possibility is not there due to energy consideration. Sharing of electron takes place and a less amount of energy is required for that, and this forms a covalent bond. For example, let us see the case of methane first. So carbon, carbon is having what? 4 electrons in its valence shell. Now what happens? It requires 4 number of more electrons. Hydrogen in its valence shell and even single cell, that is, it has 1 electron. So there will be requirement of 4 hydrogen atoms to fulfill the needs of 1 carbon atom. In this way they form the bonds, and this is a type of covalent bond which exists between carbon and hydrogen atoms in the methane molecule. So we can also do like that, because 2 electrons make a bond. So we can also write this in a manner which is drawn here. So this is what? This is a covalent bond by sharing the electrons. Now to fulfill its octet, how many electrons are there for carbon? 2, 2, 2, 2. So carbon has attained its nearest noble gas configuration by this, and it has been able to fulfill its octet. So this process do not require a lot of energy. It takes easily. So this forms covalent bond. Covalent bonds are always, remember this, they are weak bonds. And due to this, carbon forms number of bonds, number of compounds by reacting with many elements. So this was about the covalent bond formation, students. You can take screenshot of this also for your learning purpose. Now students, this property of sharing is called covalency, and in case of, you see, carbon is sharing its 4 electrons, so its covalency is 4, or we can say covalency of carbon is 4, means it is tetravalent. Tetra means 4. Tetravalent in nature. So you can also make your concepts clear now, I think. And next we come to the next step, catenation. It is also the property of carbon. Catenation is also the property of carbon. Catenation. Now students, what is this catenation? Catenation is the property by which an element, an atom of the element, and in case of carbon, हम carbon कह सकते हैं, carbon का atom element, it forms bonds with its own atom or at its own atom to form maximum number of compounds. So in case of carbon, how it happens, you see here students, like this. This is the property by which carbon forms maximum number of compounds. So this is how it takes place. Different types of compounds can be formed by self-linking of the same atom, and here carbon is combining with the same carbon atom. So this property we call as catenation. By this property, carbon is able to form maximum number of compounds. Now we come to covalent bonds first, because now here we will try to understand these carbons are attached, but they are attached with covalent bonds. So we have types of covalent bonds. Types of covalent bonds. So we have, number one is single covalent bond. Then we have double covalent bond. Then we have triple covalent bond. Single, you see an example from hydrogen molecule. Here we have one of the hydrogen, and here is second of the hydrogen. It is having one electron, it is having one electron, and these will combine. Students, they will combine to form a covalent bond. Sharing of these electrons takes place, and hydrogen attains what? It fulfills its duplet, nearest helium gas configuration. Nearest noble gas is, that is helium here. So it is, now if we talk about the other example we have is methane. In methane I have already shown you there are 4 electrons of carbon, and they are combining with 4 of the hydrogen atoms, because they are contributing single of the electron. So what is there? 4 covalent bonds, and they too are single. So we can also write it as like this. Hydrogen is this, methane is like this, because 2 electrons are there to form a single bond. So bonds are single, they are called as, these bonds are formed by sharing. So they are single covalent bond. If we talk about double covalent bond, then take the example of oxygen molecule. Here what? Oxygen, you know this, and this is oxygen. Oxygens, in case of oxygen atomic number 8, shell will be K and L. 2 electrons and 6 electrons. So 8 Now in the second shell it is 1s2, it is 2s2 2p4. So 2p4, 2 and 4, 6 electrons. Now we see 1, 2, 3, or you can write it like this: 1, 2, 3, 4, 1, 2, 3, 4 इसके हो गए, एंड 2 यहाँ पे लगाइए, 5, 6, 5, 6. Now they will combine like this. Then what happens? 2 to 4 and 4, these 8 electrons are available for this, and 2 to 4 and 4, 8 are available for this oxygen. But here 4 electrons are there and 2 electrons make one bond, so there will be, number of bond will be double, so it will form a double bond. So it is a double covalent bond. In case of nitrogen, now students, we see in case of nitrogen, you know, it is its atomic number is 7, so it will be K and L. K shell 2 electrons, L shell 5 electrons. It is 1s2, 2s2, 2p3. 5 electrons are there in its outermost or valence shell, 5 in case of nitrogen. So how it happens now? In case of nitrogen, we have one of the nitrogen molecule, and here we have 1, 2, 3 electrons are there. Second nitrogen, 1, 2, 3 electrons, and 2 of its are here, 5. 2 of its left side are here, 5. Now what will happen? How it will do? 3 of its electron will be there, 1 is cancelled from here, and 2, 3. So how? Now you see 1, 2, 3, 4, 5 of its own electrons, and 3 it has shared. So 6, 7, 8. For it, 8 electrons are there. And for this 1, 2, 3, 4, 5 and shared 3. 1, 2, 3, 5 and 3, 8. So 6 electrons are being shared, means 2 3s are 6. 3 bonds are there. So triple bond is formed. So this is the triple covalent bond. So students, this is how these single, double and triple bonds are formed. You can take screenshot of this so that you can understand it better. Later on discuss it, telling it. Now students, we talk about the allotropy of carbon. Means allotropy is what? It is the property by which an element or a substance exists in more than one physical forms. So here you see in case of carbon forms allotropic substances, or its give its allotropic forms in crystalline as well as amorphous structures. So crystalline allotropic forms are, they are diamond, you see, and graphite. And if we talk about the amorphous allotropic forms, they are coal, coke, charcoal and carbon black. Now students, first we should understand how diamond is different from graphite. You know, diamond is found in nature in its natural form and it is always colorless. Okay, impurities are added externally to give them a colorful look. So diamonds are found in nature in its natural state, and graphite is found in nature itself and can be created also. And diamond is the world's hardest known substance, and graphite, it feels softy and oily. You might know it practically. So density of diamond is 3.5, but that of graphite is 2.3. Diamond is having high refractive index and it is translucent, but graphite is opaque and black in color. And diamond is non-conductor of heat and electricity, but graphite is good conductor of heat and electricity. And diamond is found in the shape of octahedral crystals, but graphite is found in hexagonal crystal shape. Now this shape, this bonding is always there, covalent bonds are there in them. But this bonding determines how diamond becomes non-conductor of electricity and graphite becomes conductor of electricity. Students, what happens that in case of diamonds, all the four carbon electrons are covalently bonded to other carbon atoms. So, in case of diamond, which is like this, you can say, so it will again form like this. So here the structure goes like this. And again these are, so every atom, every electron, you can say every electron, all the electrons in carbon atoms are covalently bonded and no electron is free to conduct electricity if we talk about diamond. But in case of graphite, only 3 electrons out of 4 electrons of valence shell of carbon are bonded to rest of the electrons of the other atoms, and if 3 are bonded, then but the valence is 4, then one electron of each, so one electron of each carbon atom remains free, and it is thus responsible to conduct electricity. This is the reason, students, that diamond is non-conductor of electricity while graphite is conductor of electricity. So you can understand it well, I think. Talk about compounds of carbon. Means what type of compounds are formed by carbon. Many types of compounds are formed by carbon, but we have divided it into two categories: organic compounds and inorganic compounds. Organic compounds means which were initially of plant and animal origin only, but now they are synthesized in laboratory also. And inorganic compounds means which were not organic, but this was the simple classification. And organic, the feature, if we look at the characteristics or properties, organic compounds have low melting points, boiling points, low boiling points, and they are generally solids or liquids. But inorganic compounds are exclusively solids with having high MPs and BPs. And organic compounds are dissolved in organic solvents like petrol, but inorganic compounds are not soluble. And if we talk about the solubility in water, then organic compounds are insoluble in water, but inorganic compounds are soluble in water. So now, student, this was just a simple classification of the compounds of carbon. Now we talk about our next topic, that is hydrocarbons. Our topic is hydrocarbons. So students, listen this thing: hydrocarbons, compounds made up of carbon and hydrogen. They are called as hydrocarbons. Now they are divided into various categories, and the most important categorization is they are aliphatic, or you can say non-cyclic, hydrocarbons. And or you can also say open chain hydrocarbons. Open chain hydrocarbons. Second category will be opposite to it, so you can better understand cyclic or closed. Cyclic or closed chain हाइड्रोकार्बन्स जिनकी चेन बनी होती है, और साइक्लिक में ही एरोमेटिक आएगा जो कि बेंजीन होता है, और साइक्लोहेक्सेनॉल आएगा, समझ गए। और एलिफेटिक में तो सारे सिंपल ही आएंगे, चाहे हेक्सेन बोलो, ब्यूटेन बोलो, मीथेन बोलो, ठीक है स्टूडेंट्स। नाउ व्हाट हैपन्स, इसमें दो टाइप के आ जाएंगे आपके। नंबर वन इज एलिसाइक्लिक and second is aromatic like benzene. And alicyclic means cyclic aliphatic, that is alicyclic, means cyclohexane. This is your cyclohexane, but this is your benzene, aromatic. So here we have seen this. Now what happens? First take the example of aliphatic now. They are further of two types. What are they, beta? They are saturated and other are unsaturated. Saturated means where carbon is having fully filled octets in each case and there is no double bond formation in that category. So that is saturated. And unsaturated, double and triple bonds are there. This is the simple classification. So if we talk about saturated, their general formula is CnH2n plus 2 and they are also called as paraffins. If we talk about unsaturated, they are of further two types, you see. They are double bonded, which we call as, they are also, यहाँ पे जो होगा ना, they are also called as alkanes, saturated wale. And these are called as alkenes, double bonded, and alkynes, triple bonded, unsaturated hydrocarbons. Double bond between carbon and carbon in alkenes, triple bond between carbon and carbon in alkynes, and single bond between carbon and carbon in case of alkanes. You can also write this way. So this is the classification. Alkenes are also termed as olefins. Their general formula is CnH2n, and in case of alkynes, their general formula is CnH2n minus 2. So this is the simple classification of hydrocarbons. Now we can understand them by examples also. First we take alkane. You see students, alkanes. In alkanes we have methane, we have ethane. Methane is what? This is your methane. All bonds are single covalent bonds. In ethane you can also look at this. These are all single covalent bonds. But if we talk about alkenes, then it is like C2H4. So what is there? Double bond is there. Prop 1 in CH3, C double bond CH2. So here it will be CH. Then condition is clear. Now if we talk about alkynes, like this, one carbon or one bond, 3, 4 हो गए इसके, 1 3 बॉन्ड, 1 इसका, 4 हो गए. So these are the types of alkanes, alkenes and alkynes. This is how hydrocarbons are formed. Now students, let us look at how they are formed. You see what happens, we use two things in nomenclature of hydrocarbon. We use two things. One is prefix and other is suffix. Suffix is always a "-ane" and prefix is depending upon number of carbon atoms. If carbon atom is 1, it will be mit. If 2, it will be it. If 3, it will be prop. If 4, it will be but. And like this, plus "-ane, plus "-ane, plus "-ane. "-ane is the suffix. So having compound having one carbon atom will be methane, 1 carbon, 2 ethane, 2 carbons, it plus "-ane, prop, propane, 3 carbons, butane, 4 carbons. So this was how these compounds are formed and they are named. Now you have seen this thing. One concept here I discuss with you is also this, that here you see CH4, C2H6. So what is their special thing? Special is the homologous series. This is what? This is stepwise addition of CH2 group, okay, in the hydrocarbons. How? Methane is CH4, ethane is C2H6. C2H6 is what? C2H6 is CH plus we add CH2. Then C3H8 is what? C2H6 plus CH2. So there is always a jump of CH2 from one level to another, from meth to eth to prop to but. This type of series is called homologous series. So students, this was all about carbon and its compound in my first of the video. I think it will be useful for you. So bye bye.